Hello, everybody. Thank you for coming. It's a big pleasure for us to be here in our fourth Unite. My name is Amilton Diesel. I'm representing a Brazilian company called Aquiris, and which I also co-founded in 2005. So, yeah. This presentation is called Transcending Frontiers because it's about some new approaches, some breakthroughs we created in 3 different projects to solve big production problems. So I think it's not like the usual way that we normally approach some of these problems. We created very different things. For example, create a TV commercial inside Unity. It's a very new thing, even for us. And as well, other projects that we had to, for example, port to Facebook, reduce file size, and create a new terrain technology. These 3 examples I'm gonna show here, they're very unique. So the problems that we solve, they are very different from each other. We have to create different things in terms of technology, in terms of production. So I hope this can be inspiring to everyone, since programmers, artists, producers. But first of all, I would like to explain very quickly what is Aquiris in the first place, what is a company for people who don't know us yet, and a little bit of myself, what brings me here today, what gives me authority to say these things to you. So Aquiris is basically a company founded in 2005, and we are using Unity since 2007, which is quite a long time. We were also the bootcamp developer in 2009. We were invited by Unity to develop this official demo of the 3.0 version. And now we are also a 30-people studio in Brazil. We develop more than 30 games, which is a very good history for all of us. We are very proud of it. I'm going to show in 30 seconds, is very quick, a little video about some of our projects. It's just to see a little bit of our work. That's it. Thank you very much. So we basically developed a lot of different games, a lot of different styles, different genres, and this was very good because it brought us a lot of experience in a lot of different gameplay styles, and now we feel kind of ready to try bigger things, try different things. But also, what brings me here is my kind of experience with 3D design and architecture design. The company was not intention to develop games at first place. We were intention to develop architectural visualizations. And this is crazy because we ended up making games because of a market and because of external factors, not because we were intended since the beginning of developing games. So this is sort of my background. I come from the architecture, I come from the 3D design, and I also tried a lot of different things. That's why I consider myself today as a technical artist. And I tried a lot of things from digital painting to a little bit of programming. And when we started a company, we used to do these kind of things. We develop 3D perspectives to sell on the real estate market and help them to sell apartments and sell buildings, stuff like that. So at this point, if we had continued to develop the architectural visualizations, for sure we will have a successful business of our own. A small business, but it's still a business of our own. But something happened. Why we started to make games? Because that business is kind of successful. We were really pretty good at it, creating digital perspectives. But I always wanted to create real-time environments. But I had a huge problems real-time environments were not pretty because they're just a couple of 3D geometry and textures. They were not pretty at all. So I could not achieve the same results I have in the static rendering. So that was a huge problem for me. So I thought, I don't want to do that until I can't make it look good. So then I discovered light maps. Light maps changed everything. That was in 2007. So with light maps, the whole game itself changed. So we decided to develop this kind of products. So this is a real-time application, one of the first we created using light maps. And we sold that to advertising market, real estate market, in the right in the beginning of the company. So that's one of the things that bring me here. I'm really passionate about 3D environments and 3D architecture, and also for the real-time rendering. So I decided to combine these two things and created something, at least I feel, very, very unique. Oh, this is some kind of just visualizations. But of course, you might think, well, if we put a gun in the hands of this guy, we have a game, right? And yeah, it's true, that's right. So that's what we started to do. We started to make these architectural visualizations into games. So today, I consider myself a technical artist. I'm not responsible anymore for just creating environments, but to orient the whole team in Aquiris to mostly follow three basic rules when we are creating graphics. The first of these three things is visuals. It needs to look pretty. The second thing is it needs to have good performance. And the third, the more important thing is it needs to be simple to develop, because sometimes we have really pretty good graphics, but if these really good graphics are not simple to the whole team to understand how to achieve that, how each member of the team, if they don't understand what they can deliver and what they will receive from the other members of the team to deliver the work, it doesn't make sense. So in my point of view, a technical artist, the real job of the technical artist is to make the things simple. The graphic production needs to be simple and functional. So I'm going to give you three examples of recent projects we created. Some of them are released, some of them are not. The first one, The Secret of Magic Valleys, is a project that we created to Coca-Cola. And it's really breakthrough, I think, because we created a commercial inside Unity 3D. It's very new for us. Dragon Riders of Berk is a project that we created for Cartoon Network. It's actually a DreamWorks franchise. Most of you have seen this movie. And we created a new terrain solution because all the terrains on this game, they need to be vertical, and they need arcs, and they need holes on it. They are very complex. It was impossible to create that on the Unity terrain engine. And the third example, which is Quantum Conflict, Alexis from Algorithmic talked a little bit earlier. It's a project that we are developing for quite a while. We presented last year with Area Games our network solution together with ElectroTank. The bad news about this project is it will never come out as a standalone version, because we are converting it to Facebook. And in the Facebook, it will be a very optimized, very small files to make it a very accessible first-person shooter in Facebook, but with AAA graphics. So that's a breakthrough for us too. So the first of these three projects is the Magic Valleys. The Magic Valleys is a digital book that Coca-Cola created for one of their brands, which is called Capo. Is a juice for children, and is a fantasy story built around real product, which is the capo juice, and tell the story about a family and care. Is intended for children, but is also intended for parents. Is a real breakthrough for the advertising agency because they trusted. They put a lot of money in a game engine to develop basically everything. Different than happens most of the time that they develop the commercial, they develop press advertising, and they direct only a small amount of money to develop the game. In this case, was the opposite. They developed everything based on the Unity technology. And this is the kind of things that only Coca-Cola does, because they can do that.
A centenária fazenda Del Valle esconde segredo. Diz a lenda que lá existe portal que leva aos vales mágicos de Del Valle Capo. Reino encantado, onde são feitas as bebidas mais amadas pelos seus filhos. Seja bem-vindo a uma surpreendente aventura que vai unir uma família e ajudar pais e filhos a se aproximarem através dos divertidos desafios da natureza. Acompanhe a jornada de Nori, Beatriz e Sam em busca dos segredos do carinho. Você e sua família vão se divertir jogando e lendo cada capítulo dessa história. O segredo dos vales mágicos de Del Valle Capo. Embarque com seu filho nessa aventura.
Yeah. Sorry about the Portuguese speech. This project was intended to Latin America. So the Secret of Magic Valleys has all these different products: TV commercial, iPad games, browser games, and press. Everything generated from the same source done in Unity. So the main problem was everything on this project started with a movie, not with a game. The game is derivated, it comes from the movie. So we have a huge problem here. We have actually only two options. Or we outsource the production of this movie to in a traditional way. We hire a company that will use traditional tools, 3D tools, to create the movie, and then tweak it on After Effects and everything, and assume all the risk and all the cost of doing that. Or we decide to produce that inside our company using our real-time stuff. Well, you know that game companies and movie companies are very different from each other because they have different hardwares and they have different know-how of the people. So we started to compare both possibilities, and we start to realize that it's not that difficult to develop a movie inside a real-time engine. Of course, it's not the most obvious. It's not the most obvious solution, but it's quite possible. But if not everybody does that, what are the limitations? Why the people are not looking at it and trying to make movies inside a game engine? Is that the geometry problem? Maybe real-time engines cannot render in a lot of geometry. I think that it's not a problem because that was done inside Unity. That's an actual screenshot of one of the scenes we created for the capo, and it's pretty complex. It has millions and millions of triangles, so polygons is not a problem anymore for a real-time engine to develop a movie. Maybe texture. Well, texture, not really. These are textures from a movie. And they are, of course, they are pretty big, and there are 4 pretty big textures to develop a single character. But today, 1 GB video card can store a lot of textures in the DXT format because they compress a lot, and they can be very flexible in a 1 GB video card. So maybe there are other features that are quite impossible to simulate, maybe lighting, shadows, and reflections. Yes, these features are kind of different because they're more advanced. They are not like the video cards are used to do, the video cards are intended to do. Like GI, for example, real soft shadows, blurry reflections. But depending on the job, depending on the art direction, these features are not a huge bottleneck, because sometimes you just need good art direction. You just don't need GI and don't need advanced reflections. Pixar, for example, created a lot of movies on their rendering engine that doesn't have GI at all. So this can be inspiring for creating a movie inside Unity. Maybe post-production. Post-production, I think, today is a real bottleneck because they are quite heavy, they are quite expensive to render in real time. And in movies, they use a lot of it. They tweak each pixel of the movie to make it look perfect. So in real time, that's not possible. So, but you can find some middle ground solutions to do that. So I think it's quite possible. That's the result we could achieve doing a TV commercial in Unity.
E aí, o que vocês fizeram ontem?
Ah, atravessamos vales mágicos, passamos por rios de suco de fruta, visitamos um castelo.
Nossa, onde é que foi isso?
Na fazenda Del Valle. Lá descobrimos como o Del Valle Capo é feito. Com um suco de frutas de verdade, cercado de natureza por todos os lados.
Você vai adorar o mundo mágico de Del Valle Capo. Um lugar onde seu filho cresce saudável e se diverte.
So yeah, it's short, 30 seconds only, but it took a lot of work to do that. So basically, we created very detailed environments to reproduce all this detail, all this complexity of a movie requires. And these scenes have millions of polygons. It's very complex. Of course, it doesn't run really fast. But since we have this complex scene inside Unity, we are able to capture the frames, and we can do a movie. So you can see that there's a lot of post-production effects in a pile. So we almost use all of post-production effects available in Unity 3. So when we hit play, you see that there is a blue screen that we will mask after that to make sure that the movie is still running behind of it, because the kids are still moving their arms on the table. So there is a mix between the real acting and the movie created in Unity. So that's it. So we need to capture frames, and this capture need to be perfect. So when we gather all these frames in After Effects, for example, they need to represent the same time step from each other, so the movie will run smoothly. Then we created a script that it just advances a fixed time step and renders a frame, and save this frame, and we get this frame after that, put it into After Effects, put them all together, and we have a movie. So this is just how is the pipeline of saving the frames. It's not exactly real time, but if we compare this almost real time to the traditional technology that takes days to render in a movie, that's really fast. And it's not just fast, but you can do that in your own computer. You don't need a rendering farm to do it. So it's different. Now it's when the videos blend to each other, so we need to mask it and cut the blue screen in After Effects later, so it will be blended, the Unity 3D capture with the real action capture behind. So we created the package of the juice in 3D, and it's like that, everything in the same space. We just arrange the animation camera and make sure that everything will fit after we we capture the frames. So that's in After Effects. We just use a simple color key to remove the blue background, so we can see the kids moving behind it. And we also use some post-production effects that are not available in Unity 3. For example, motion blur or radial blur. These are sort of the effects that are still not quite possible to do in real time very accurately today. So this is the radial blur we applied. And that's it, the movie running in After Effects. So the second step of the project is to create the digital book. The digital book has some characteristics. It needs to be very real from outside and very magical from inside. So this is the home of the digital book. You are in a kid's room, and you are able to play with the environment, play with the basketball, close the curtain, play with the lampshade. But then, when you get inside the book, it's a whole new world inside. It's very magical, it's very different than reality. And there's a lot of content there. There are 30 chapters and more than 300 pages.
Bia e Sam seguiram Joane até uma marina com dezenas de submarinos. Sam e Bia giravam de mãos dadas no ar. Raios cruzavam o vazio.
Uhul! Dá um frio na barriga, né, gente? Por isso
So, of course, that's what kids like. It's not exactly a book, but it's a magical world inside a book. And to do that, and in a huge amount of content, we take advantage of the previous detailed world that we created for the commercial and baked it and make sure that the real-time environments will look almost like the same. So it's kind of that process. You know, this is one of the pages of the book, and we have all these low-poly meshes out there. They are baked from the high-quality meshes, and it's here. We have everything there, and it looks almost like the same high-quality mesh that we created for the commercial. So the other step of doing a very complex book, a very realistic book, is it seems to be silly, but it's quite challenging. How can we balance the density of the pages so we can make sure that if the user opened the book in the beginning, it will reveal a different amount of pages, and if he opened the book at the end or in the middle, it will be different. So we kind of make a character book to doing that in 3D Max. It's kind of difficult to rig a book. We never did that. But you can see the change of the density of the pages when the book is closed and the book is opened. We kind of mixed, kind of blended 4 different animations just for the change of density of the pages and for the opening and closing. But the book itself doesn't have pages. The pages are attached to these helpers. They are also a skinned mesh, and they attach dynamically to these helpers, so we can move any page from any part of the book, and they will always fit. Doesn't matter the density of the pages we are viewing. So you can open the book at the beginning or in the end, and it will load correctly the amount of pages.
Eram 8 da manhã.
The last step of the project was to port it to iPad. So it is kind of a journey. It started with a commercial, and then goes to the web, then goes to the iPad, and goes to the press, everything with the same source. But actually ported to iPad was kind of simple because we just had to reduce some textures and of course reduce alpha and color blending, like you could see in the previous presentation that alpha blending is a big problem in the iPad and iPhone hardwares, mostly Power VR. And of course change the inputs. So we could easily port the game to iPad just doing basically these 3 things. So it's exactly the same project as you can see in the web.
Também tinha sido o melhor dia da vida de Bia e Sam. Os mergulhos de Splash, o passeio em submarino de Joanne, o trem alucinado de Potential, o voo. Mas é injusto. Paizinho Fontaine's. Ei! Parou a confusão. Atrás deles, uma. Nosso leite vai coalhar? É isso aí. Outra vaca se aproximou. Essas famílias...
That's the end of Secret of Magic Valleys. So the second example, Riders of Berk. This is a game for the DreamWorks franchise, How to Train Your Dragon. And the most challenging part of creating this game is because it's a very known franchise and they have all these Viking islands and these complex environments that we need to recreate inside Unity. And the complex part is we need environments big enough so the dragon can fly through it and found a lot of space to do a lot of things. But at the same time, we have the character. They need to walk across a small village, walk across these environments, and they still find a very detailed environment to explore. Because the focus of the game is these 2 things at the same time, the flying environments and walking and exploring. Because this movie actually is about to turn into a TV series, and in this TV series, all the kids of the village will be able to catch their dragons, to pet their dragons. So that's what the game is about. But what kind of complex environments am I talking about? I'm talking about something like this. So how the hell we're going to create this with a proper terrain tool? That's quite impossible. Like this, or like this. That's hard. So the solution we found for this project is to create terrains almost in the same way that we develop characters, which is using ZBrush, 3D Max, and mixing with some well-known terrain texturing techniques, very scalable techniques. So this is the combination we need to find to produce these terrains. So everything starts on ZBrush, exactly in the same way like we were doing a character. So all these rocks and all these complex things are sculpted in ZBrush. At the first beginning, we thought, well, ZBrush maybe is too heavy for such a small solution. But in the middle of the process, we realized, well, that's the opposite. Maybe ZBrush is faster than developed directly in 3D Max. So we created the rocks in the very first beginning in ZBrush. This is one of the examples. And then the other important part is we cannot just export these heavy meshes to 3D Max because they were all messed up. Their geometry will be like hell. So it's really important to retopologize, to rewrite all the vertices and make sure that they will be lightweight and they can be ported to a real-time solution. So that messed up mesh is what comes from ZBrush, and we cannot use that. But since we retopologize and we rewrite the geometry above the ZBrush geometry, then we can have a complex environment, very detailed modeling, but easy to develop inside ZBrush. So yeah. Then the next step is texturing. That's when the things are starting to be harder, because texturing such a complex geometry requires a good UVW mapping and requires a lot of work. But at the end, we realized that it worthwhile. So until now, is the same process of developing characters. This is the kind of finished geometry inside 3D Max. So we apply UVW mapping and open all these UVs like we were doing a character, taking special attention for the areas where the player will walk, because these areas need to be more detailed. So we use a 3D Max tool called Viewport Canvas. It's like a Photoshop, but in 3D, but inside 3D Max. You are able to work with PSD files and work with layers. It is a lot more powerful than paint the terrains inside Unity, and we can have more flexibility. We have more power doing that inside 3D Max. So we just paint it and use layers and create the first texture of our terrain that we call base map. This terrain, this texture, this base map looks like that. It looks like a mess because the terrain is huge and has a lot of detail. But that's the first result in Unity when we export the base map. So the second step is the splat map. So now it comes to mix the character development techniques with the terrain texturing techniques. So the splat map works pretty much the same way as the splat map in Unity engine, which separates RGBA channels and it chooses from what color will represent which texture. So the splat map is doing like the same way. These are tieable textures that they will give detail when we are looking to the terrain from close distances. And this is the shader. It's almost exactly the same as the Unity terrain shader, but we can customize it. So we can also work with layers. So if I turn off, for example, the green layer, which represents the grass, I will turn off all the grass in the terrain. You can see it's still green because the base map multiplies all the textures below it, but we cannot, we removed all the grass from the terrain. And if we turn the green layer again and paint some more green on this wall, when we get back to Unity, it will be, the grass will be back and there will be grass on this wall. This is very useful because it's kind of seamless pipeline work. It's kind of the same thing that work in 3D Max, work in Unity, go back and forth, and see the results. And the last step, and the more painful one, I think, is object placement. Because since we are not using the terrain engine to develop our terrains, we are doing a simple mesh, we don't have a proper tool to display, to place all these objects. And the lighting is done with the same Beast Light Mapper available in Unity Pro. No big deal on that. Yeah, so the objects are still placed by hands, but they still can have LODs. So they are not be combined by the terrain engine, but they will be still lightweight, because the LODs, the far LODs, can be very simple in this case. That's what we did to all the trees and all the meshes that will be placed on the terrain. So this is the results of our terrain technique in how to train a dragon riders of bird. much, Riders of Berg. So the last example of what we consider technology breakthrough, transcending frontiers in quantum conflict. Well, this game we are developing for about 2 years, I think now. It was intended to be a standalone game, so we don't have limits to file size. We can apply as much textures as we want. But since last year, we have some business issues. We decided to change our publisher, and with this next publisher, the game is intended to run on Facebook, but with one condition: we need to keep the same good graphics we had in the standalone version. So the only way to do that is basically compressing a lot, because if we want the game to be accessible on Facebook, the files need to be small and the performance need to be good. So that's pretty hard to do. And that's why we decided to use Substance to do that, because Substance is a good way to generate lightweight graphics, lightweight textures, photorealistically, and make the game look beautiful, but with small files. That's sort of a comparison we did using bitmaps and substances. In this left, we have the previous version of the game running on standalone. I think that was developed in 3.0 version, so we didn't have some of the cool stuff we have in 3.4, like HDR, for example. So that's why the graphics looks slightly worse than the Substance version done in 3.4. But 4 bitmaps by 4 texels by centimeter square is a pretty high resolution for texturing a game. It's not high resolution when texturing an FPS game, because you will always see the texture from pretty close view, but it's still a high resolution. So we kept this resolution, we didn't change it, and in the standalone version, a single level has 80 megabytes, and in the Facebook version, it has only 8 megabytes. And that happens because textures, mostly always, they are guilty for generating such huge files in modern games. They take a lot of data, because we are used to see the games become more beautiful and more beautiful. So in Quantum Conflict, to make this conversion, we decided to use 2 types of substance. The first one is completely procedural. What I mean by completely procedural is that there's absolutely no influence of bitmap in these textures. They are basically made from nothing, made from scratch, using just procedural operations. The second one is bitmap more procedural, which means we are starting from a bitmap from a JPEG texture, which is only a diffuse texture, and then we use procedural techniques to compress this texture, generate the specular, and generate the normal map, which means we are only storing in a single material, a single diffuse texture, which is also compressed with JPEG instead of storing 3 different textures. They are not JPEG compressed, just DXT compressed. So this is a comparison of one single texture that we converted in the Quantum Conflict project from the standalone to the Facebook version. So this is a pretty big texture, is 1024 to 2048. It's a complete material because it have diffuse, specular, and bump mapping, I mean normal mapping. And if you put this material in an empty scene and publish it to the web player, it will generate this file, which is 4.6 megabytes, because it's a huge texture. If we build the same texture in Substance, that will be the file size, is 160 kilobytes. And that texture was completely developed inside Substance Designer. There's no bitmaps there. They might look slightly different, of course, but during the game, this is not noticeable. I mean, you cannot see which one is bitmap or which one is procedural. And why isn't everybody doing that? Because it's hard. Develop 100% procedural texture is hard. You need really good artists to do that, because when we develop 100% procedural textures, we are trying to basically create the nature, create something very complex. Because nature is about imperfection. Nature is messed up. And we need to simulate that when we are recreating procedural texture. It's not just like the surfaces, that when we see a wall, it has cracks and it has dirt and it has a lot of imperfections. It's not just that, because the human eye and photographs are also imperfect. So you can see it as digital painting, which is a very good digital painting that is an artist I like very much. You can see that in such a small spots of this digital painting, if we amplify it, it shows a very complex palette of colors in such a small amount of the texture of the painting. What is this guy doing? Is simulating perfection. He's simulating photographing perfections, because all these waves and rays and lighting bouncing around everywhere, they just mess up the photographs. Doesn't matter how good your camera is, there will always be artifacts. And that's why develop procedural textures is hard. So this is a concrete texture. I think it's a pretty good one. It was totally developed in Substance, and it's totally procedural. But the hardest textures to develop in Substance Designer are the flat ones. It's not the dirtiest ones, because in the flat textures like concrete and like brick, for example, it's far more easy to notice if the texture is bitmap or if it's procedural. So there are some good practices to develop good procedural textures like this one. One of them I will point out is mixing color noises. Like you saw in the previous painting, there's a lot of colors mixed in such a small spot. So to create these concrete textures, we mix at least 5 different color mixes and 3 masks, tweaked in a very, very carefully to achieve this result, which is a flat concrete texture, but a very good one, a very convincible one that you can put in your game, and the people will not notice if it's a bitmap or if it's a substance. Other important detail is you need to create each detail in the correct scale, and that's hard for people that are not used to compose their own textures. For example, this old brick wall has a lot of different sizes of bricks, different dirts on them, and different sizes and details on the mortars. So the most common results that people achieve when they try to do this procedurally is something like that, and that's terribly wrong, because when the user gets into a game, he will notice almost instantly that this is a procedural texture, because the bricks are too aligned and the texture is not convincible. It's just like a noise. But the one in the right represents the correct representation of this bitmap, which has different sizes of bricks, have different textures on each brick, and the mortars are sometimes positive, sometimes negative, sometimes it doesn't exist at all. It's exactly the same effect that we have in this previous bitmap. Another important detail is microcolor variation. That's exactly the same effect that you saw in the painting, because there's no gray in the nature. Nothing in the nature is completely gray. Nothing is grayscale. Everything has color, but the colors are so mixed that we cannot notice that with our eyes. But when we took a photograph and see it like in a microscope like that, you see that there's a lot of different colors there. You need to simulate that when you are working with procedural texturing. There is also macro color variation, which is a huge variation of colors that might be generated for, I don't know, maybe a wall that the painting got slightly different near to the skirt board comparing to near the ceiling because the lighting is different there and the painting got unsaturated in some parts of it. So it's important to also simulate this macro color variation. You can see that the texture below seems more natural. Is not, the red is not so, no, don't gain your attention so easily. Another important good practice to get good procedural textures is grayscale warps. I mean, why grayscale? Because we are showing a lot of parameters and seems like we need very complex graphs to develop good procedural textures, but that can be kind of a trap because you cannot build so complex graphs because it will take a lot of time to generate the textures. And always when we do grayscale operations, we are doing just in the grayscale channel, which is one channel compared to 4 channels in the RGBA color standard. So it will be 4 times faster. And the grayscale warps are very good to create all these cracks and all these imperfections that the nature has in all the surfaces. This is the second kind of substance we created. They are not as powerful as the previous one because they use bitmaps. They are not so powerful, I think, because they will not represent such a small file size as the previous one, but they are powerful because you are also using bitmaps, so you can develop your texture perfectly on Photoshop before compress it on Substance Designer. So this is a regular texture, I mean 3 textures, a single material created in Photoshop, diffuse, specular, and normal map. And this is a scene published for web player with only this texture, and is 1.3 megabytes. The same texture using Substance, it takes 224 kilobytes, which is also a good decrease of file size because you can imagine a game that has hundreds of these weapons, it will represent a lot, this reduction. But you can also think that, well, but if I'm not generating my specular and my normal map so carefully that I did the diffuse map, because I composed the diffuse map in Photoshop, and I will not have this freedom to do the remaining 2 textures, it will not be the same result. Well, I agree with that. It will not be the same result, but sometimes it doesn't matter. Because you can see this comparison of this M16 gun. That's using the bitmap files. It has diffuse, specular, normal map, and a reflection. The shader is a reflective, bumped specular. So it has the same file size. And this is the one created with the Substance textures. And it's pretty much different, but I will not say which one is better. They are just different. Depending on the art direction, I would say that the Substance looks even better, because specular maps and bump maps, they are not so important as the diffuse texture. Making a good diffuse textures is a lot more important than having good specular maps and good bump maps. So, I mean, some of you already saw the results of this game running on the web with 8.7 megabytes. You see in the previous presentation from Alexis, but here's another video to show that. During this time, this intro, we are decompressing all the textures. So we just download the 8 meg files and get it directly into the application. In 8 megabytes, there is the sound, the meshes, there is everything. This level is for 16 players. It's not a big one, but it's also not a small one. So in the game, the levels will not be much different than 8 megabytes. I think the maximum will be 15 megabytes, maybe for the huge ones, for the largest ones. So that's it. Thank you so much. And if you have any questions,
yeah, hello.
hello.
What kind of difference in the loading time does it take with the procedural textures?
You mean the downloadable data or the decompression files inside the
Well, I'm
application?
guessing what actually generates the textures inside Unity.
Well, it depends on how optimized you develop your textures, because since the Substance Designer, you can customize everything and put everything you need, like levels, like warps and filters. It can take a long time to generate all the textures if you do that very complex. But if you do that very simple, like these ones we created for this demo, all the textures, and I think there might be 70 to 80 textures on this level, it takes around 7 to 8 seconds on an average machine.
Okay, thanks.
Hi. I had a question about procedural plus bitmap.
Yeah.
So are you just taking your bitmap images and running them through some process
Yeah.
in Substance, and it kind of spits out a similar image? Is that simple?
Can you? I don't understand exactly.
Like you were showing, you had it looked like hand-painted textures.
Yeah.
And then you showed what it was like with bitmap plus procedural. It was a frame. I can't remember exactly what it was, but you had 3 maps, and they looked pretty similar. But how do you process a bitmap plus procedural?
Well, that's related to the operations that Substance is capable to do it, because what we do here is basically there are a few steps to generate specular and normal map from the diffuse, which is converted to grayscale, make it a high pass, exactly the same high pass out of Photoshop, make a levels, a sharpen, and that's the specular. For the bump is the same high pass, and after a blur, and after a mix of these two, and the same levels, and the normal map filter. So that's the kind of the operation you need to manipulate the diffuse textures and generate the whole material. It's not really complex. It's like the same thing you will do in Photoshop, but organized into operations.
Hi. I want to flip back to the two previous projects before this.
Okay.
And ask about the move from, or the decision to use a game engine to make a film commercial.
Yeah.
The question is this. You said that the technical procedures and methodologies were obviously moving closer and closer together. Real time, render farm, all that sort of stuff makes not that much difference. But I'm interested in what your take is on the design and creative processes, because my impression is in the film commercials and film world, we're interested in quite different things, in story, and so it's not necessary, and maybe it's the talent which is different, and how you bridge that. Did you learn from it? Did they learn from you? That sort of thing. Could you talk a bit about that?
Well, I think it's a sharing process. I don't know exactly how to explain that, but of course the talent of the people, it matters a lot. It matters more than the technology itself. That's why I decided to show that most of the things that most people will think it's a problem to create a film in a game engine, they don't really exist, because you can create very good stuff with good art direction. And that's why we decided to do the film inside Unity. So we have very talented people that are very used to compare these two different qualities, the game and movie, and they know what kind of effects they need to simulate in a game engine to get the same results of the movie. So one of the reasons I decided to show this example is like to open the minds that there are more things that Unity is capable of doing besides games. We can also develop movies. It's just a matter of tweak the effects and work well with the art direction, and you can go there. You can still have it.
Do you think you could have used made use of a really well-trained film editor or a well-trained cinematographer in some of those sequences? Do you think that would have upped the production value, or do you think it would have made no difference?
Maybe if we had to develop more than just one movie, because for this one, we basically used the built-in timeline of Unity. We didn't create any specific tool for creating the movie, just a script to capture the frames. But if we are intending to develop a lot of movies, we are like I want to be a movie company that works with real-time engine. I think there are a couple of tools that will help a lot to develop a movie in a real time.
Tools or people? Tools or talent, which?
I think both, because one cannot live without another. Yeah.
Thank you.
How long it took you the render of the screenshots
for each sequence?
For a sequence.
It takes 3 or 4 times more than the real time. It's really fast. It takes around, I mean, the farm sequence, the tree sequence, I think it takes around 2 or 3 minutes to capture all the frames, because it's not real time. We have a lot of post-production there. It's really heavy, but it's still trying to, the engine is still trying to render it as fast as it can. So it's really hard to compare to traditional 3D tools like 3D Max or Maya, for example, because they are so much slower, you know, in real time. For us working with simple laptops, simple PCs, this is a huge advantage. It's really fast.
The script you made it? You were the ones?
Yeah, we created it in Aquiris, yeah. Okay. I don't made it myself, but other guy made it.
Okay, thank you.
It's a very simple one. It just advances a fixed time step, saves a frame. Advances time step, saves a frame. Just that. That's it. So, thank you very much.